Coming to the very important concept in the electricity chapter, the most important concept, and even in the public examination also, there is a most possible to come one question from this concept. A very important concept is Ohm's law. Is Ohm's law. What is this Ohm's law? Why it has the most important concept in the chapter electricity? As we discussed electric current and potential difference. Electric current and potential difference. Potential difference is work done to move a unit charge from one point to another point in a conductor. Whereas electric current or simply current means amount of electric charge is flow in a conductor in a 1 second. Here the Ohm's law gives a relationship between the electric current and the potential difference. Electric current and the potential difference. So, Ohm's law is stated that, or the Ohm's law is stated that, are defined as at a constant temperature. At a constant temperature. Ohm's law definition. At a constant temperature, the current flowing to a conductor, through a conductor is directly proportional to the potential difference. Directly proportional to the potential difference across it ends. So, if the current is flowing in a conductor, that current flowing in a conductor is directly proportional to the potential difference. So, this is the very important statement. One of the very important concepts. At a constant temperature, the current flowing through a conductor is directly proportional to the potential difference across it ends. So, according to the Ohm's law, current is directly proportional to V. So, here current directly proportional to the voltage, or we can call as potential difference V according to the. So this can write as, to remove this proportionality symbol, we need to write a constant. This should be written as V proportional to I. So where at constant temperature, at a constant temperature. So from this we can write V is equal to, in place of proportionality symbol, we can write a constant R and write I. This should be written like this: V is equal to IR. V is equal to IR. So this is the Ohm's law equation. V is equal to IR. So here R is the resistance. R is the resistance of the conductor. R is the resistance of the conductor. So the value of this constant depends on some factors we will discuss later. So the resistance of conductor depends on some factors. They are nature of the material, length, area of cross section, and temperature. After this Ohm's law, we will discuss the factors affecting resistance. So from this equation we can write from the formula V is equal to IR. From the formula V is equal to IR, we can write R is equal to V by I. R is equal to V by I. So simply we can say that the ratio between the potential difference and the current flowing to the conductor. The potential difference, the ratio between the potential difference of conductor and amount of current is passing to a conductor. So potential difference by conductor. So resistance R is equal to potential difference by current. Again from the same formula we can write, so V is equal to IR. So one formula again, then this is taken as the other one. So we can write I is equal to V by R. I is equal to V by R. So how many are there totally here? 1. This is the 2 and this is the 3. 1, 2, 3. So I is equal to V by R. So from this you can understand that current flowing in a conductor depends on the two factors. One is potential difference and resistance. So here we can write again potential difference. Again we can write potential difference by resistance. So current flowing in a conductor depends on the two factors. One is potential difference and the other one is the resistance. So from the above relationship, the current is directly proportional to the potential difference. And current is inversely proportional to the resistance. So direct proportional. It is indirect proportional or inverse proportional. Direct proportional or inverse proportional. So direct proportional. So if the potential difference is high, flow of electric current also double. If the potential difference is doubled, then the flow of electric current also doubled. So in case of direct proportional, if one quantity is increases, then other quantity also increases, right? Since the current is directly proportional to the potential difference applied across the ends of the conductor, it means if the potential difference across the ends of the conductor, so for example simply we can take it. So just this is connected to a cell or a battery like this. This is the A and B. So this is the conductor. This is the conductor. So for example, you can take it as any resistance. Any resistor like a bulb. Or take a bulb also, no problem. So flow of electric current direction. Notice switch on and then the bulb goes. Then the bulb is blue. So here the bulb is acts as conductor or a metallic wire, any resistor, whatever. So just imagine that if it is only a wire, is connected like this, is connected like this. This is the one end and this is the other end. Between these two ends there is potential difference. So the amount of electric current is passing through a conductor depends on the potential difference. If the electric conductor has more potential difference, then the current also flow more. So the potential difference across the ends of conductor is doubled, then current flows also gets doubled. If the potential difference is half, then the flow of electric current also half. Similarly, if the resistance of the conductor is more, then the flow of electric current is less. If the resistance of the conductor is doubled, then what about the flow of electric current? So get half only. If the resistance is half, then the current gets doubled. So whatever, if current is indirectly proportional to the resistance, more resistance, less current. Less resistance, more current. Here more potential difference, more current. Less potential difference, less current is more. So current flowing, amount of current flowing in a conductor depends on the potential difference and the resistance of the conductor. So let us understand now resistance. Let us understand what is the resistance. Resistance of the conductor. Resistance of the conductor. As we discussed earlier, so due to the movement of the negative charges, nothing but the electrons, current can flow in a conductor. While this movement of electrons in a conductor from one part to another part, the electrons are collide with another electrons, or the atoms, or are the ions in a electric conductor. So due to this collision between the moving electrons or between the moving electric charges, obstruct or oppose the flow of electric current through a conductor. So this property of a conductor, due to which it opposes the flow. So the property of a material or the property of a conductor, the property of a conductor are a material which opposes the flow of electric current, due to which it opposes the flow of electric current in a conductor. Is called resistance. So the property of a conductor or a material due to which opposes or obstruct the flow of electric current through a conductor or in a conductor is called as flow of electric current through a conductor is called as resistance. So why the flow of electric current is obstructed? Because electric current is nothing but the flow of electrons. The flow of electrons in a conductor is called as electric current. While the electrons are moving in a electric conductor from one part to the other part, the electrons are collide with the atoms or the ions or the other electrons. Due to this collision, it causes the obstruction of flow of electrons. While you are running fastly, what will happen if the many people are moving in your way? Sometimes what will happen? You are able to hit other, then your speed is reduced. Then your flow can stop or your running is stopped for few seconds based on the collision. Similarly, the electrons are moving in a conductor. They collide with the other electrons or the atoms or the ions in the conductor. Due to this reason, it obstructs the flow of electric current. So the property of a conductor or a material which obstructs or opposes the flow of electric current is called resistance. So the SI unit of resistance is ohm. Resistance is ohm. The symbol is like this. So the symbol is called as omega. So ohm is the SI unit which is denoted by the symbol omega. The unit of resistance according to the Ohm's law. We write R is equal to V by I. So 1 ohm is equal to. So from this formula we can write R is equal to V by I. So potential difference voltage you can represent with voltage V and electric current with 1 volt by 1 ampere. 1 volt by 1 ampere. So 1 ohm is equal to 1 ohm of is 1 ohm is equal to 1 volt by 1 amperes of current. So 1 ohm is the resistance of conductor. 1 ohm is the resistance of conductor such that when a potential difference of 1 volt is applied to ends, a current of 1 ampere can flow through it. Means if the conductor having 1 volt of potential difference, then 1 ampere of current is flows, then it is equal to the 1 ohms of resistance. 1 ohms of resistance. 1 ohms of resistance. So this is about the resistance. So this resistance of conductor, is depends on some factors we will discuss later. Based on the resistance of conductor or a material. So these materials are classified into 3 types. One is good conductors, resistors and insulators. Good conductors, resistors and insulators. Those substances have very low electrical resistance. Low resistance. Those conductors having low resistance, you can call as good conductors. Those substances or those materials, those substances having low resistance are called as good conductors. Those substances which have comparatively high electrical resistance. So those substances having comparatively high resistance are called as resistors. Examples of resistors are the alloys like nichrome, manganese, constantine, all have high resistance. So they are called as the resistors. The filament of the bulb also resistor. Nichrome. So nichrome, manganese, constantine are the example for resistors. So that's why these resistors are used in many electrical appliances. So electric iron is made of nichrome wire, which is a resistor. Then the substances which have indefinitely high electric resistance. You can call as insulators. Rubber, plastic are the examples. So based on the resistance, the substances are the materials having low resistance are the good conductors. Copper for example. Comparatively high resistance are called as resistors. Nichrome, manganese, constantine are the examples. So the nichrome used in a electric iron. Then those having highly resistance, those substances having infinite high resistance, those materials are called as the insulators. Examples are plastic and rubber. So this out. Now let us take some experimental setup to prove Ohm's law. To prove Ohm's law. After we will discuss the graph and